Hi, my name's Steve Murphy, and I'm with Teledyne LaCroix, and here today we are at Salig Company in Rochester, New York, and looking forward here to present to you the new the HDO high definition oscilloscope, the 4000 series, and just to show you some brief information about this this oscilloscope. This is again a 12-bit high definition oscilloscope. 12-bit ADCs with 2.5 gigasamples per second sampling rates. Each channel has dedicated ADCs in them, and each channel will go up to 25 million data points and interleave to 50 million data points on 2 channels. So lots of memory to work from. When you're using a scope to validate your circuits, or you're trying to find things unexpected and then do some troubleshooting and debugging, this really is the best scope. 8-bit scopes definitely were useful, but now with 12 bits tied in with the features I'm about to show you, makes this a real powerful scope and unique in the industry as well. So show you here is, you're comfortable, you've been using other scopes, and if you're new to LaCroix, I'll just tell you just quickly, if I touch the channel descriptor, all the controls for dealing with the channel are listed right here. If you want to change the coupling, I would do that just right here. Whether you use the AC or DC coupling, or your 50 ohms or 1 mega ohm input impedance, real simple. If you're going to use a differential probe and look across a current sensing resistor, well, you could put the value of the current sensing resistor in here. You can type in anything from specific values, or put your own number in here for the value of the current sensing resistor. And then you can change the units to amps. And with the sensitivity set to variable, you can have now have the result of the scale factor for that channel to be to match exactly what the value of the resistor is in circuit. So quick and easy way to get to current using this display. But again, the menus are really very easy to use, and if you want to set your trigger, for example, just touch the trigger descriptor, or you could touch it on the front panel in the setup menu. Either way is fine. Or if you want to use the touch screen, you would go up to the trigger and do trigger setup and display the trigger dialog section from the pull down menu. So 3 ways to access it. You'll choose which one you like and what you're most comfortable with. Again, I just like touching the channel, the trigger descriptor, and it brings me right to the channel dialog. So all the triggering you need is right here, and whether it be simple edge trigger with or without hold off, and qualified trigger about triggering on one channel but only after you've seen something else occur in another, or looking at serial, or looking at, in our smart triggers, you can also look at glitches and intervals and runts and dropouts, or DVDT, DIDT, and how, for example, a MOSFET turns off, and triggering within a range of certain values is all done in the trigger menu. So the product itself here, the HDO, is a family of oscilloscopes. It's 200 megahertz is what it starts with. Has 350, 500 megahertz, and 1 gigahertz bandwidth choices. There are some 2-channel versions of the scopes at the 200 and 350 megahertz. Otherwise, all the other scopes are at 4 channels. There is a mixed signal option. You'll want to consider that at the time of purchase, or we can retrofit it after. But right in here, this is where you would add in a probe pair that would give you 16 channels of digital inputs. And that can be tied into for acquiring 16 plus the 4 channels, and all of that can be trigger conditions on any one of those inputs to the scope. I think you'll find that there are tools built into the scope that make analyzing and actually measuring waveforms pretty easy. If I go up to measure right here, and we can go ahead and turn on a parameter table, and we can add different measurements to it. I'm just going to go ahead and add in amplitude measurements, and I'm going to add in frequency, width. And so no problem in just turning on statistic and making these measurements. So all the tools for making parameter measurements using cursors, taking that up to 50 million data points and creating segments so that each are triggered events, so you capture only what you need to capture, is done with this oscilloscope using history mode. You'll see that most of the key important features for validating your circuits are right here, from a history mode to spectrum to wave scan and decode. I'll go into these a little bit later with just with other videos, but thing to point out that I like to use here is under Lab Notebook, that allows you to take this image and this waveform and save it as a report. So I'm going to do that now. I'm just going to keep the timestamp as a unique identifier for this report, and I'm not going to add in well, I'll add in some text, right? You can add some text to tell you more about the report. And then we'll hit OK and save, and then I'm going to go ahead and do some documentation, drawing on it, or circles, whichever. But anyway, we'll put this into memory and then save it as the report that we can then also look in and view as the report, including a flashback. So I'll get into that a little bit more, but for documentation tools, for making measurements, for exporting data in Excel format or MATLAB format, for triggering on all the right information, the right parts of a waveform that are of interest, this scope has all of that built in. It starts at $9,000 US and on the 200 megahertz oscilloscope. And please contact Selig Company, because they have the expertise here to support you and provide more details as you need them. Thank you very much.